told that strontium-90 is a radioactive material and it decays according to this function. Now it's given in function notation, but if you prefer to just think of that as A equal, that's fine. E to the negative 0.0244 t. Now what does this other stuff mean? A naught is the initial amount present. So what that means is that means at t equals 0. And you can see that from the equation. If you put in t equals 0, your exponent becomes 0, e to the 0 is 1. 1 times this gives you the amount, A naught. And A is the amount at time t, which is in years. So we're starting with a 1,500 gram sample. First question is, what is the decay rate? So this is just a matter of using the formula. The rate is in the exponent multiplied by your time. So if I want to put it as a percentage, I'll have to move the decimal place twice. So this is 2.44%. It already says on the problem decay, so I'm going to use a positive number here, but I would accept negative 2.44%. Anytime your rate is negative, it's going to decay. Okay, so either one of these would be fine. If it just said what is the rate, you would want to include the negative, but it already specified decay, so I don't need the negative because that's going to be repetitive. How much of the sample remains after 10 years? Well, we want to put it into our formula. A equals, now A naught is the initial amount. We started with 1,500. 1,500. E to the negative 0.0244 time is 10. Just a matter of putting this into the calculator. Watch and make sure that in your exponent you have the multiplication, so that all needs to be within the parentheses. And I'm getting this to be about 1,175. I'm not told how much to round to, but I am in grams, so I could use decimals. And let's just look what we've got here. Oh, let's go 2 decimal places. 3 grams. Okay, part C. When will 1,000 grams be left? So that's telling us how much we have at the end. And remember, we started with 1,500. So it's back in reference to the original problem. If it wants you to refer to something else that we've done, like part B, it would say that. Okay, so we have 1,000 equal 1,500 e to the negative 0.0244 t. So first divide by the 1,500. On the right side I get just the exponential. On the left I can reduce some. That's going to be 10/15. I know it reduces more, but at least that's less to write, and I know I'm going to round at the end. Again, take natural logs, because that's how we solve our exponentials. And because this is base E, we get very nice property with our inverse properties. That's going to cancel and just leave us with the exponent. So we'll have natural log of 10/15 equals the exponent, negative 0.0244 t. And we can solve by t with just dividing. Of course, I want to use a calculator for that. So natural log of 10/15 divided by negative 0.0244. And it looks like t is approximately, let's do 16.62, and this is time, which is in years, so this would be years. Now, last problem is similar. It says, what is the half-life? So here, half-life is the time it takes for half of the substance to be left. Well, if I started with 1,500, I'm looking for the time it takes for half of that to be left. So over here I will have half of 1,500, which of course is 750. Now, exponential equation. To solve, first step is divide by 1,500, and what do you know? Over here you get half. Very similar to doubling, tripling time with an exponential equation. I don't even need to know that I started with 1,500. I could cut right to a half equal just the exponential with no number in front if you're cutting down to here. But you can certainly go with the amount and then do that as well. So now use natural logs. Once again, because the right-hand side has a base e inside the log, just like with the previous part of this problem, that cancels and we're just left with 0.0244t. So t is going to be the natural log of half divided by negative 0.0244. And once again, we'll use the calculator to approximate. Oops, 1/2. And it looks like this is going to be about 28 point, let's see, we've rounded 2 decimal places everywhere else, so we'll do that here again. 4-1, and we're in years. Makes sense that this takes longer than the previous because this was getting us down to 1,000 grams, and this one gets us down to 750 grams.